Hey, what's up, guys? Welcome to another episode of the Modern Goonies podcast. I'm your host, Trevor King Minor, hanging out with my badass co-host, Michael Ross.
Once again, it's your boy, Michael fucking Ross.
So, welcome to Season 1, Episode 7, and tonight's topic is Cosmic Supervoids. So, yeah, we're always throwing a lot of words at you guys, and I'm sorry, I didn't realize how science intensive that this entire season was going to be. I was like, oh, this seems pretty well balanced between just like bullshit and science, and I was very wrong. But anyways, we're gonna get into it, and Michael's gonna kind of steal the show on this one because I was busy this week and didn't really do a whole lot of research, but I got the gist of it. I mean, it's a pretty simple concept, I would say.
I would say so too.
Yeah. Okay, so what is a cosmic supervoid? So we're talking about it in terms of the universe, and a supervoid is basically like a giant swath of space where there aren't a whole lot of galaxies. It essentially looks like just a giant dark spot in space. And we cannot overstate how monumentally huge these giant swaths of empty space are. Because some of them are literally billions of light years across, which you can't wrap your head around that. So, Michael, why don't you kind of mention some of the things that you thought were pretty interesting about this? Because I know you've been dying to talk about it this week.
Okay. So, I would like to start with, I guess sort of a sense of scale. So, we're going to talk about atoms for a second and how many there are.
Always starts with atoms.
Yes. So, on Earth, in a typical cubic meter of air, or in a 3 foot by 3 foot by 3 foot cube of air, there are 10 trillion atoms. That is 10 to the power of 28 per cubic meter. At 100 kilometers up in space, like up above the Earth's surface, there are 1 million trillion atoms per cubic meter, which is 10 to the power of 20 atoms. At a third of the distance to the moon, there are 7 million atoms per cubic meter.
Okay, so we're starting off just throwing a brick at our audience right now. That's what we're doing.
We're going from 10 trillion to eventually we're going to 10.
Yeah.
10 atoms per cubic meter. So
fucking Christ. And keep going.
So bear with me. It's almost over. In the space between stars, there are 1,000 atoms in every cubic meter. And in the space between galaxies, there are roughly 10 atoms, 10 single atoms between galaxies, in the space between galaxies.
And this is not within a supervoid length. This is just in between galaxies.
I mean, that's sort of what you could expect in a supervoid, because a supervoid has 10% of the matter density of like the regular universe. Sorry, of a more populated region of the universe. So like there are just, for example, 10% of the galaxies.
Yeah. So shit. So like when I read a little bit about this, so the way I understood our universe is it's comprised of what's known as walls, and it's comprised of what is known as voids. And a good chunk, I want to say, I read like around like 80% of the observable universe is actually comprised of voids, like kind of the spaces in between galaxies. So there's always kind of voids in between galaxies, and those aren't really too big of a deal. But then there's the fucking gigantic ones, which are the super voids in between galaxies. So that's what I kind of understood. But one of the things that blew my mind, and I kept trying to figure out what this was, because I had thought about it like years ago, and I tried to look it up, and I couldn't quite like put it into words. But filaments, which I think those are so fucking cool. So can you kind of describe in more layman terms like what a filament is?
So in layman's terms, a filament is just a string, and string is sort of misleading because you think of string as tiny, but this is like a galactic string.
If you zoomed out far enough, it would look like a string of galactic structures, like planets and your whole galaxies.
You would see galaxies.
Okay, yeah,
like
there we go.
It would be too small to see planets.
There we go. Yeah, that's what I meant. Yeah, like that's pretty nuts because that was the thing. Like if you zoom out far enough, they call it like a cosmic web. Like it looks like a spider web, the way that all of the galaxies kind of like intertwine with one another. And so like when you're looking at all these strands, there's obviously kind of spaces in between the strands, and those are voids, and some are supervoids. But I always thought that was cool because, you know, some people have said, I say some people, probably like fucking Reddit users on the internet, I don't know. But like, you know, when you zoom out far enough, it kind of looks like a web, but it also kind of looks like, you know, like neurons in the brain, like the way that they are like interconnected. So it's like, you know, some of those hippy dippy people are like, the universe is alive. It's a living entity. We are within something's brain. It's like, well, that's kind of cool to think about. Like if you zoom out far enough, it looks like neurons. Like that's pretty cool.
Yeah, I mean, I think there's a nice symmetry between the cosmos and like biology. Like for example, a supernova looks, if you look at the right one, of course, it looks like an eye. And like you said, the cosmic web, as we believe it looks sort of like a bunch of neurons.
Yeah.
It's incredible.
It's pretty dope. I've always been one of those people, probably because I saw some kind of video about it when I was a kid, but it's like, I always just thought like, you know, if you just kept zooming out, it eventually, everything would kind of like we're actually just like subatomic somewhere. But if you kept zooming out, then eventually it would be like a normal world. And then if you keep zooming out of that one, it's just like this endless zoom out of subatomic to fucking universal. Like I always thought that was like a pretty cool concept.
I thought so too. The Simpsons actually did something like that.
Yeah.
Like that exact concept on one of their introduction scenes. And
maybe that's where I saw it from originally. I don't know. I had seen some kind of like animation of that once, and I thought it was like, I don't know. I thought it was like, ever since then I'd be like, yeah, no, we're all just subatomic.
Yeah, like that's a very cool thought to toy around with.
Yeah, it's pretty interesting. So supervoids, you know, there seems to be a lot of things that like kind of defy the laws of physics, or it's just kind of like leave you scratching your head, because one of the things about it is that when you look at the image of the cosmic background radiation and you see those gigantic supervoids on it, like you can see their imprint where they look like, they're like cold spots, essentially, like cold spots in the background radiation. One of the problems that we have with it is that some of these things are so unbelievably massive, like I said, like billions of light years across, that they wouldn't, based on our math, they wouldn't have had enough time to get that far away, like for galaxies to be that far away from each other in the amount of time that it took the, and how old that the universe is. So, you know, once again, it's another weird ass thing. It's like, okay, how do we explain that? And it seems like one of the solutions is dark energy. Actually, they say that gives like more credence to dark energy, because it's like, look, it'd be impossible for these things to be so far away if they weren't accelerating in their expansion, which clearly, I mean, they have to be like that. So it, it gives more credence to the fact that there's dark energy probably at play there. But still, like, it's pretty weird to think about that. Even they're like, they look at this like, well, that shouldn't be possible.
Yeah, and something else. The single largest structure in the universe sort of speaks to that as well. Like, if the single largest structure in the universe is what we think it is, then we have to rethink our cosmology almost entirely.
So what's the largest structure in space? I know, yeah, I see that
I am glad
smile on
you
your face.
asked. So, the largest structure in the universe is called the Hercules Corona Borealis Great Wall. It is roughly 10 billion light years across.
Holy shit, okay.
So if light traveled from one end of this superstructure to the other, it would take almost the age of the universe to get there.
Really?
Yeah.
And so how exactly does this present a problem in like some of the way that we think of this stuff?
Because it's too many galaxies, like too much matter in one place for it to make sense in our current cosmological framework.
So do we have any potential solutions to that?
Not that I've read.
Really? Fuck. Okay, so it's just a big head scratcher.
Yeah.
How long have we known about this thing?
Since 2013.
Okay, wow. Yeah, you see, that's the crazy thing about space, that we're always finding shit that's kind of like, fuck, something's off. Like, it's like we have some potential answers, but fuck.
It's exciting.
Oh, no, it's cool as shit. And that's one of the things that I like about science so much, is that it's not like well, we found this thing, but fuck it doesn't fit in our mass, so it doesn't exist. No, it's like, fuck, something's wrong. It's like we got to figure out how to either make this work, or we got to kind of toss the book out on some of this shit.
Yeah.
Yeah, that's one of the things that I like about science so much, is that, you know, we constantly discover new things, and then we're like, all right, back to the fucking drawing board. So one of the crazy things, so there's a couple of these voids that are absolutely ungodly huge. The three that I keep seeing more than the others is so there's one that very uncreatively is just called like the Great Void.
So I believe that, if my reading was correct, the one that you're talking about is also called the Eridanus Supervoid.
See, I don't know about that. Wait. Fuck.
Because in my reading, I saw that it said, I mean, I could be butchering this name. It might be Eridanus, but the Eridanus Supervoid or the Great Void.
I've heard it pronounced as the Eridanus, but what I was reading, it made it seem like they were two separate things.
Oh.
I said I was getting super confused reading some of this stuff, because the way that they classify it is it's kind of hard to wrap my head around. So like they have like a list of like, here's the most gigantic ones, but I guess some of them haven't been like completely confirmed or not, even though they can like see a lot of them. And so it's like, oh well, I kept seeing that the Buotes is
the Buotes.
Buotes.
Yeah, I think
Whatever,
that's how you say it.
Whatever.
I mean, somebody said it in my astronomy course, and I believe it was Buotes.
Buotes. Yeah. Well, I kept watching videos, and everyone kept saying it differently. The Buotes.
That's how I'm going to say it.
Okay, the Buotes one is like, there's like, this is the biggest one, and then I'd see the KGB one. It's like, this is the biggest one, and then I'd see another one like the Eridanus or the Great Void. Like, this is the biggest one, and then it's like, oh yeah, well that's the biggest one, but it doesn't exist. And I'm like, okay, I don't fucking know what the fuck is going.
Admittedly, the Eridanus Supervoid is, like, what it is right now is a cold spot in the cosmic microwave background map.
That is one that is consistent. I kept seeing that, a giant cold spot in the CMB.
And it makes sense to say that it is a void, but it's not like confirmed. Okay. So it's technically not the biggest void, because we can't say it's a void yet, but a void fits the description of what that cold spot could be.
Yeah, because I did see some things about cold spots, and it's just kind of like areas where you just can't see the light on the other side, so it looks like a giant void, but it's actually just kind of like essentially like a space cloud, like on a cloudy day or some shit. But I have seen that a lot of people seem to be in agreement that it is a void.
If we're talking, sorry, there's actually something that I came across that is similar to what you were just talking about, being blocked out by clouds. Mm-hmm. And since we're talking about extremely massive objects, have you heard of the Great Attractor?
I was seeing things being referenced to that, but I didn't look into it at all. So what is it?
So there is some object hidden behind the Milky Way's plane. So like if we're looking straight on, like at the Milky Way, all we see is like light and clouds. Mm-hmm. There's something behind the Milky Way that we're just unable to see. And it is millions of times more massive than our own galaxy.
And I'm assuming we know it's there because of its effects on the things around it.
Yeah, so we are in this enormous supercluster called the Laniakea supercluster. It contains 100,000 galaxies. And even though the Laniakea supercluster is not gravitationally bound, there are a shit ton of objects moving towards whatever this Great Attractor is that we just can't see. We are moving towards the Great Attractor.
So do we have, I mean, obviously we can't see it. Do we have any theories on what it is?
I have no idea.
You have no idea. Okay. Yeah. No, I didn't. I've heard of things like that before, but I didn't look too much into it.
I think it's so fucking interesting. There's this million galaxy object that we just can't see that's pulling us in. What the fuck?
Yeah, that's I don't know. Fucking space is weird, man. It's so it's so loopy. Okay, so I had a question for you because we constantly keep referencing the cosmic background radiation, and I keep seeing, if you look at it, there's this picture of it, and I'm assuming what is that picture when I'm looking at the cosmic background radiation? Like, is that the observable universe? Like, is that just looking out in one direction and that's what we see? Like, how the fuck could we possibly even map out an entire universe on like a 2D plane like that? Can you explain that to me a little bit?
Yes. So I had the same question as you. Like,
Okay.
I think that map initially is very hard to understand. But from what I know, that map is basically a projection of the sky that you can see like all over the Earth, but you cut the projection and lay it flat.
Oh, okay. So
from a certain point on the Earth, you can see like the cosmic microwave background. Sorry, that's a shitty explanation. From a certain point on Earth, you can see like the quote unquote spot where the Eridanus supervoid lies. So that's mapped. There's a point, I mean, everywhere that you can see on Earth or pretty close to the Earth is mapped.
So it's like a giant composite.
Yes.
Okay, that makes sense. It's funny. My dad and I were just kind of like talking about how cars kind of do that, and security cams do that, where it's like, you know, they kind of turn it into a panorama of everything, but even though it's like only looking in one direction, but it can see in like 5 different ones, and then it digitally puts them together, and it's like, this is actually what your 360 view would be like, and it's exactly what it would look like. So, okay, I was so curious about that because I was like, how in the fuck does this work? Yeah. I'm just sitting there looking at this. I'm like, how?
That is not the entire universe.
Yeah.
But, fun fact, the observable universe is 93 billion light years in diameter. That's massive.
Yeah, it's fucking huge. Every time we mention anything about space, it's so fucking huge. I can't even wrap my brain around any of it. So one of the things that I wanted to mention, so the Buotes, is that right?
That's, yeah, Buotes, that's what I say.
Motherfucker. Okay.
It's right to me. And the person I talked to in grad school.
The Booty Cheeks Galaxy. Supervoid, I mean. So if you were to place this in the middle, and I kept seeing this line said by every fucking person that I looked this up on. Like, I watched like 10 videos on this, and they all fucking said this sentence. So I guess Modern Goonies is obligated to say it as well.
Here it is.
Here we go. If you were to put us in the middle of the Buotes void, we wouldn't have known that other galaxies existed until the 1960s. That is how massive this void is. So we would have never known. We would have looked up in the night sky. We would have really only seen like our local group of galaxies, but we would have never known that other galaxies existed if you just put ours in the center of this thing until about the 1960s. Whenever I can't remember what huge thing was that, the Hubble. I don't remember.
I thought Hubble was in the 30s.
Yeah, it was something significant happened in the 60s where we looked out into the night skies and we oh yeah, no, yeah. That's right. Yeah, because Hubble, we discovered that in about the 20s or 30s, and that's when we could see it. But so like, if we had that same level of technology, we would not have been able to see galaxies in the 20s.
That doesn't surprise me. Yeah. I mean, just thinking of how long it would take for the light to reach us in a fucking void. Oh, that is perspective.
So that's one of the another interesting thing is that some people think that we are either within or we are right on the edge of a supervoid. And I can't remember which one was it. It was the KGB void. They suggest that that we could be inside of that one currently.
Interesting. So, I mean, I'm not one to go against experts who who probably have more intellectual weight than I do in this area, but sorry, did you say super void or regular void?
Well, the KGB void is a super void. It's a massive. It might be the biggest one. It's fucking huge.
Okay, see, that's crazy because, I mean, I know we're part of the Laniakea supercluster, which is a composition. I mean, it's composed of 4 sub-superclusters, and a supercluster is just an enormous collection of galaxies, in case I didn't make that clear.
Yeah.
So, like, it's understandable that if we are in a supercluster, then there is a void nearby, because at one point there was a whole bunch of matter. I mean, still is. At one point there was a good distribution of matter throughout the universe. The matter coalesced because of gravity, and wherever the matter came from, a void was left behind. I mean, does that make sense?
Yeah, no, it does.
Yeah. So if you're in a supercluster, then almost by definition, you are, relatively speaking, very close to a void.
Yeah, so then I think that's more what they mean. So like we could be right on the cusp of the KGB void, which is like this massive super void. So we could technically be in it, technically not be in it, whatever. But it's still kind of like crazy to think about because, you know, the way we keep describing it, it's not like this void like, you know, eats things and is like completely dark. It's basically just like there's not near as many galaxies as should be around. So I think like if we take like one of these massive super voids, and I don't know which one this was, but whatever, we'll just take one of them. They say like within it you would expect about 2,000 galaxies, but we only found like 60 or something fucking crazy, like not many at all. So like there are galaxies within these super voids. It is just an incredibly small number compared to what it should be. So like 2,000, and I think one of them literally only had 17 in them.
That's so fucking cool. I want to visit this place, man.
I don't. Fuck. Fuck that. It's like,
I want to see what it's like.
It's like eternal darkness. You're just dead in space.
God. So we haven't actually used typical measurements to describe voids versus supervoids, like order of magnitude estimates. And I think that's sort of important to establish a sense of scale, if that's even possible with something this large.
Go right ahead. Throw another brick.
So a void is typically 30 million light years across. That's a regular void. And to give you some sort of perspective, a typical Milky Way-like galaxy is 100,000 light years across. So that is, let's see, what is that? 10 times 30. That's 300 Milky Ways lined up side by side or end to end.
Jesus fucking Christ.
So with that, we have supervoids, which are on order 300 million light years across, or greater, of course, or greater. And that is, what did I say? 10 times what I said before. Whatever it was. 3,000 Milky Ways?
I don't know.
I think that's correct.
Jesus Christ. So to put this in a little bit more perspective, I just, I shouldn't have done this, but I just Googled how many miles are in 1 light year.
Oh, dude.
Holy fucking Christ.
Trillions.
5.879 e to the 12th.
Okay. 5 million is 6 billion. Yeah. So 5 trillion, almost 6 trillion.
Yeah. So that's 1 light year. So about 5 trillion miles in 1 single light year. So now imagine some of these, which are literally billions of light years across.
Yes.
And that's just a void. That's just blackness. So trillions upon trillions upon trillions upon trillions keep going for like 10 minutes, light years or miles wide.
So imagine if the fastest thing in the universe takes, say, 1 billion years to cross this thing.
Mm-hmm.
Then if you were going at highway speed across the void, it would take you so many years.
Understatement.
Like, so many is an understatement. You are right. I couldn't even tell you, like, off the top of my head.
We just have to say our, like, dumb monkey brain measurements.
Like, effectively, it would take you an infinite amount of time.
I mean, just think about, like, you know, concept of a light year. Like, it takes, you know, light 1 year. Traveling at the speed of light, it takes it, like, 1 year to get there.
Yeah.
So, you know, just upon that name, 32 billion light years. It's like, all right, well, we know how long that's going to take for light, which is the fastest moving object in the universe.
Exactly. Exactly.
Yeah, that is absolutely insane. Yeah, these things blow my fucking mind.
Hell yeah, dude.
I feel like every podcast we've had when we talk about space stuff, I say the term blows my fucking mind, like probably 10 times within the podcast.
Excuse me. I mean, this is a good thing. Like, if people are interested in this stuff, I hope it blows their minds too. Now, for a little bit, I would like to talk about the cosmic microwave background. I don't have much, but I would like to just explain the significance of the theorized Eridanus supervoid.
Okay.
So, typically, the universe is pretty homogeneous in temperature. It's like the same everywhere.
Right, yeah.
Like there's a very even distribution, and the quote unquote cold spot is only 0.00007 Kelvin, which is basically Celsius, colder than the surrounding area. That is not very much colder at all. Like,
really?
You would not notice that. Nobody would notice that. Like that's, let's see, what is that? That's basically 0 degrees plus 200. Fuck. It doesn't matter the exact fucking bullshit. Our fucking temperature sucks, but that's basically the same temperature. Typically, the difference in temperature that you would expect is like 0.00018. So the number that I said before is 70 microkelvin compared to the typical expectation of 18 microkelvin. So this is a massive difference relatively. But as a whole, the universe, if I remember correctly, is about 4 degrees above absolute zero, basically everywhere.
Really? And isn't absolute zero like some kind of unfathomable temperature? Like
absolute zero is where all atoms stop moving. Like
holy
even the
fucking shit.
thermal vibrations that atoms have
Good Christ.
stop.
That's insane. No, yeah, so I guess in the grand scheme of things, that's not much of a difference, but that is like considered a cold spot. I don't know.
Yeah.
Still, it's weird, yeah, because some of it, because we talked a little bit about the CMB beforehand and in our universe beginnings and endings, because it's one of the things that proves that the Big Bang was a thing, and it's just funny because it's like our math works so well in all of these concepts, but then you get these one or two things here or there that it's just like, motherfucker, this such an anomaly. Like the, not the pillars of creation, but the other thing
the Hercules Corona
thing.
Borealis Great Wall.
Fucking Christ. The Great Wall. I'll just call it the Great Wall. There we go. Yeah, like that. Or then like this. It's like, okay, well, there's not quite enough time for this to happen, but here it is. And then, well, we basically had to come up with the idea of inflation because of the way it's all evened out throughout. A lot of the math doesn't add up sometimes, and sometimes it does. I don't know. It's crazy.
So speaking of the beginning of the universe, the reason things are the way they are today, from what I've seen, is because when the universe was in its extremely hot, dense state before inflation happened, there were like quantum fluctuations happened, and that's just a fancy way to say the energy at each point in space varied by a random amount for like an instant. That's all quantum fluctuations are. Just small changes in energy and space. Quantum physics demystified. Boom.
Boom.
So random changes in energy cause ripples in whatever the fuck was in the big, like the compact version of our universe. So when inflation happened, those ripples carried over, and as soon as inflation happened, like roughly around that time, those ripples caused dark energy to coalesce. And not dark energy, dark matter. And because whatever dark matter is, it's gravitationally attractive, regular matter was attracted to that dark matter. And then, like, that's how we have a cosmic web.
Yeah, I mean, that's really fucking cool.
Sorry, I forget where I was going with that, but that's the origin story.
Of the cosmic web.
Slightly more specific.
It's pretty fucking cool, though. I like it. So here's one thing. I want to know what you think about this. So I just, you always got them throwing out, like, the random dumb ones, but also cool at the same time. So some people suggest that some of these, gigantic, mega, ultra supervoids, like where it's just this giant, weird, cold spot in the CMB, are potentially where a sister universe collided with ours. Did you see anything about that?
I did.
What do you think about that?
So I think it's interesting, and like from what I've read, the only way for that to be true is For reasons I can't understand, there would have to be another supervoid at almost the polar opposite location in the universe where one supervoid was discovered. I don't know why that is, but if there is a second supervoid antipolar, or like basically at the south pole of the universe, if the first void was at the north pole, I mean, that's, I'm not going to say evidence, but it's compelling.
Interesting. Okay, so yeah, so basically you're saying if for whatever reason we found one on one side and then one on the exact opposite of the other, that would be like pretty good. Like, okay, that might have happened. Like another reality touched ours for a moment or some shit.
Yeah, I mean, beyond that, I don't think there's a way for us to test it. But
yeah,
like based on that, I don't think we could say, hey, this didn't happen.
Right, yeah. So another thing, and this doesn't really relate to supervoids, but I guess it could. But so you know, we're always kind of looking at like the observable universe, and then we have the CMB, and we have all this shit. But universe is so unfathomably large. Is it possible at all that like what we're just seeing is not even a fucking fraction of how big the universe actually is?
So I'm glad you asked that, because there is a reason that we call it the observable universe.
Right.
Yes. So there, it's likely that there is a universe that there's something out there that we just will never, ever be able to see because enough time hasn't passed. So it's not observable. Like we have to wait for that light to reach us before we can comment anything on it. So there are sections of the universe out there that we just will never be able to see as we are right now.
Right.
And I think that, like, I've read estimates that is like 216 billion light years in diameter, but that's just fucking insane.
Yeah. So in theory, it could be possible that our little thing could just be like a small circle.
Oh yeah,
on like this fucking football field of universe that we just will never see.
That is entirely possible.
That is fucking crazy. Oh my god, it's nuts to think about just how unbelievably insignificant we are.
Yeah, dude, it's so fucking cool.
Well, yeah, I don't know. Space has always been one of those things where it's like, you get caught up in your office job and you're going to and fro and making money and you're arguing with your parents about whatever, like just like some dumb shit of like, oh yeah, gays should be able to adopt your kids, but just stupid shit. And then it's like you kind of forget that you're on like this spinning rock that's hurtling towards space at thousands of miles an hour with a fucking giant heating globe like right next to you. And then if you keep zooming out, like you're not even like a grain of sand on a beach compared to fucking how much there is out there. And it's like, yeah, no, we kind of focused on some stupid shit down here on Earth in our little granule.
Dude, if we could see, like, if we could take a look at a table and on that table was the universe, we would be microscopic. Like, we would be like atom-sized.
Exactly.
We are the atoms of the universe.
I'm telling you, we're just something else's subatomic. That's all we are. Like, you zoom out of the universe a little, like too much, and it's just a fucking, I don't know, it's some kid's left ass cheek. Fuck, I have no idea. But
we're on the supreme being's ass cheek.
Yeah, there we go. Yeah, imagine how insignificant you'd feel then. It's like, really? That was the answer to everything?
Bro, imagine like being in the eye of whatever the fuck. Like, oh. Bro.
It's so annoying because it's like, we got all these things. It's like, I want to know the answer to all this goddamn shit. Like,
I know.
And it's like, it's almost just not fair to be brought into this universe that's just like thriving with all of these fucking like questions and like so much mystery. And it's like, yeah, that cool ass mystery? You'll never know. You'll never know.
See, space is actually one of two reasons why I want there to be a life after death.
Yeah.
Like, I imagine if there's a life after death, I won't be bound by anything. I could have the vision that I want. So I could see an X-ray, like I could see across the entire light spectrum, not just invisible light like we're limited to. Mm-hmm. So I could go see anything. I could see the fucking cosmic microwave background. I could see gamma rays coming from fucking the giant gamma ray burst ring that I'm going to talk about in a little bit.
All this reminds me of, though, is like if you were granted that power just out of nowhere, you'd be like the kid Superman in the Man of Steel movie where he's just like, oh, I can see too much. He's like freaking out in a fucking closet, having a mental breakdown. Like that's exactly what would happen.
You're right. It would be so fucking cool, though. Like, imagine being able to see. I mean, I guess it would. You would be able to, quote unquote, see a black hole in greater definition because you could see more light coming out of, not out, but coming near the event horizon.
Yeah.
Like, you wouldn't just have visible light. You would have just about all the fucking wavelengths. It would be very bright. Like, brighter than it is now.
Yeah, so your version of an afterlife is basically just being a space ghost, just floating around looking at shit the whole time.
I would have such a fun eternity.
But what if it took you still like billions of years to travel across? Like, would that be a deterrent?
I would have billions of years, man.
I think I'd go mad. I'd go space ghost mad.
I would marvel at everything, dude.
Just hurtling through space.
Oh, dude, you're definitely gonna have to lower the.
Yeah. I heard a cut on that one. Anyways, you can go ahead.
So, super hard left segue. The giant gamma ray burst ring. I have 1, 2. I mean, technically 3. I've sort of talked about the. Whatever. So I've got 3 massive structures that I haven't mentioned in sort of detail. And one of them is the giant gamma ray burst ring. So the giant gamma ray burst ring is 9.1 billion light years away. And it is 5.6 billion diameters. Sorry, 5.6 billion light years in diameter. That is... sorry, I was going to say like that's 33% of our universe's diameter, but that's a fucking lie. It's about 5%.
Oh, okay.
5% of our observable universe's diameter, because that's 93 billion light years.
But what is this thing, though? I mean...
So it is a collection of, I think, 9 very active gamma ray burst objects. That's all we know.
Gamma ray burst objects. So like something that would emit a gamma ray.
Yeah, so it could be black holes, could be neutron stars, but whatever these objects are, they're like very far away, so we can't really, I mean, we can't see them. We can only take a guess at what they are. We have telescopes that can resolve the fact that there are 9 separate gamma ray bursts. But like I said, we can only guess at what they are. That takes the title of the largest regular formation in the universe.
So what's the difference between that and then the one? I guess one would be irregular. The Herculean thing is irregular.
Yeah, so the thing, I'm going to say its name because it just deserves so much fucking weight.
Let it roll right off that tongue.
The Hercules Corona Borealis Great Wall.
And I'm hard.
So that isn't like a regular structure because it's a fucking...
too big for physics to even have an answer for.
Well, it's difficult to put into words, but imagine, like, I guess it's the difference between saying, God, this is hard to fucking put into words.
It's like how my right nut is normal, but my left nut is slightly more elongated from the go-kart accident that I had when I was a kid. There we go.
Hell yeah, sure.
So you can't base all of your perceptions of nuts around if you just saw my left nut. Because you'd be like,
you'd have to see the right nut.
You'd be like, oh my God, go to a doctor.
God, I wish I could explain this better, but it's difficult.
We'll just stick with the moron explanation.
Yeah, left nut versus right nut.
There we go.
There's also the Sloan Great Wall, which is similar to the Hercules Corona Borealis Great Wall, but except it's about 10 times smaller, or 1/10 the size of the Hercules. And it's about 1 billion light years away, whereas the Hercules is, I just realized I don't have a distance estimate. I imagine it's just that fucking big that it doesn't matter how long, like how far away it is.
Yeah.
In addition, something that I think is pretty monumental about the Hercules Corona Borealis Great Wall is that gamma ray bursts were used to estimate the size. I don't know how, but
I don't either.
So the tip of the iceberg, what I do know, is that too many gamma ray bursts were coming from a certain area of the sky, then it made sense in our current predictions of how the universe should be. So, calculations, observations, boom. This is like a Great Wall, potentially.
Jesus.
Yeah.
I don't even know. So like the Great Wall, what? It's just made of like stardust or some shit, or like what is it made of?
A shit ton of galaxies. Like,
okay.
This is insane.
Interesting. So then the Pillars of Creation, that's like stardust, right?
Yes, the Pillars of Creation is a bunch of stardust, and I can't remember if there are stars forming in there, but I imagine there are.
You see, and then that's something else, because like, you know, every time I have that image in my head, it's like super dope, and then I'm like, wait, is that just an artist's like rendition of it? Like, what do the Pillars of Creation actually look like?
I think the color that you see in the Pillars of Creation are like, it's a composite image based on like various wavelengths of light. I think if you actually looked at them, you wouldn't see it like that.
Gotcha. Yeah, well, I even type in real, and then it's like clearly the artist, and these are still like artist renditions. Yeah, I mean, nonetheless, it's pretty dope. Yeah, that's nuts. That's pretty fucking cool. It looks like God's hand.
Yeah,
it's fucking awesome,
dude. Fucking stellar formation, galactic formation, just formation of shit in the universe is massively interesting.
Yeah.
And it just happens on such large timescales that it's actually kind of unfortunate that we only live 100 years when all of this stuff happens on the billions of years timescale.
100 years. I'm about to live 25. I'm out.
That's it. Yeah. I'm going to join the 27 club.
No, not even that. I'm starting my own 25.
25.
Yeah, I know, it's insane. So one of the things that I did want to mention is that so earlier we were talking about how our universe may be either within or on an edge of a supervoid.
Mm-hmm.
And we've talked on this podcast in previous episodes, not in this season, but kind of, you know, pre-season existence. We talked a lot about the Fermi Paradox. Which isn't, I don't really want to bring that up too much. I mean, we could probably bring that up whenever we talk later on one of our topics that we have, but that I did see that could be one of the answers to the Fermi Paradox. And for those who don't really remember, it's just basically like, our universe has been around so long, where are all the aliens at? Why don't we see them? That's the Fermi Paradox.
The Fermi Paradox is asking, where are the hoes at?
Yeah, where are all the hoes at?
Sorry, that might be offensive.
I don't give a fuck. Where all the galactic hoes at? So that might be an answer to why we don't see them, is that we are within the edge, or we are within like a supervoid. And as we know, since if you're on a pretty remote location, or if you're out there looking for life, you're probably not going to look inside of a void to find alien life out there. So it could be one of the reasons that we have never been contacted.
Damn, I have not considered that.
Yeah.
I mean, I'm not saying like I'm a paragon of fucking knowledge or anything, but like, holy shit.
He's like, holy fuck, we figured out the answers to the universe.
Yep.
On the Modern Goonies podcast.
That's it. We're in a void.
Yeah, we're in a void. We all just get sucked into a black hole immediately. I just see your 1,000-yard stare. Oh God, no.
Dude. Imagine, okay, you just made me think of something. So imagine the largest black hole.
Mm-hmm.
Let's see. We talked about this last time. So, I mean, not last time, but maybe the one before. It has an event horizon of 390 billion kilometers. That is less than a fucking light year, dude. Huh. And these voids, they're fucking shit. Billions of light years.
Yeah.
I mean, if the Eridanus supervoid is actually a void, it's 1.3 billion light years in, length. And that is fucking massive.
Yeah. Like I said, you throw us in the middle of one of those, we wouldn't even know other galaxies are out there.
Dude, I just want to, can I take a moment to appreciate just how inadequate the word remote is?
Sure.
Okay, so we're going to do it. So imagine you're on a remote island. What goes on in your mind? Are you surrounded by the ocean? Do you see dolphins? You might see a bird, one single bird, maybe.
Yeah.
But you're with the water. You have sound. You have light.
Oh God.
I mean, you have the sun as company.
Mm-hmm.
You have more company than you would if you were in a fucking void.
Not where I thought you were going with that.
Like, oh God. So if I just grabbed you, somehow placed you into the middle of a fucking what this supposed Aridana Supervoid
You are a
is,
malevolent god.
and I gave you the ability to survive there. You didn't need oxygen, food, water, anything. You could survive. You might not even see stars. You would not hear anything. You would not see anything. You would not fucking... I mean, you'd be cold. You'd be really cold.
I sure as fuck wouldn't pray to you, let me tell you that. I'd be angry at my God for placing me in this hell.
Like, you would be the most... Excuse me. You'd be the most remote object in the universe.
Yeah, that's horrifying. But I think what's more horrifying is imagining like just me sitting at my fucking kitchen table and a giant hand reaches out from the fucking sky and throws me into a void. It's the worst drug trip of all time.
Dude, to put you into a void, like if we're talking about speed, if you were to not break any laws of physics, okay, that's impossible. If you were to break the speed of light, you would be vaporized if I were to just grab you and then drag you to a void in less than a second.
Oh, like, yeah.
You would dematerialize so fucking hard.
Well, that reminds me of, you ever seen that video of like how realistic Superman's punch would actually be? Did you ever see that shit?
God, tell me about it.
I've seen this video a couple times, but basically like they were going off of like how much strength he had in the comics, and apparently one time he was so unbelievably strong he punched like a hole in the universe or some shit. So it's like they like calculated that out, and basically they're like, all right, say you're in like fucking Los Angeles and he punches you. It would set off like a bomb that would basically destroy like all of California, and like you would just be like, the second his hand got near you, you'd be liquid plasma. Like fucking this completely fucking melts you immediately.
Damn, so all the people that Superman has punched, if it were real, they would be dead.
Yeah,
they'd be more than dead.
You see, thank God retconning is a thing, because if Superman could constantly, hit his enemies with the force of ripping a galaxy apart, I mean, there'd be no Earth to stand on.
Yeah. God. Imagine Earth is ground zero for like... Okay, I was going to say 9/11 for galaxies, but I don't want that to be in the podcast.
Oh my God. Yeah, no, I'd be pissed if I was just some regular space dude. And this one planet decides it's gonna blow itself up through some fucking demigod that punches like, I don't know, a squirrel or something. God.
Yeah, holy so shit. Is that going in the podcast? The Galactic 9/11?
Probably.
Oh God. Damn.
Galactic 9/11. Holy shit. It's all right. We were young when it happened. It's been 20 years. Yeah. This year's 20 years. We can make jokes about things that happened 20 years ago. Fuck, we make jokes about things that happened a year ago that we probably shouldn't. So
that's all right. We do what we do.
We play with fire here at the Modern Goonies podcast.
That's right.
All right. So you have any other interesting things you want to mention before we start to wrap up?
No, I think I've actually mentioned everything on my notes.
Yeah, so I want to thank you guys so much for tuning in to another episode of the Modern Goonies podcast. I have been your host, Trevor King Minor, and this has been my badass co-host, Michael Ross.
For once, I'm just going to say, what's up? It's me.
I don't like it. So join us again next week for Season 1, Episode 8, and we're going to take a bit more of a lighter tone this time. We're going to stray away from some of the space stuff, and then just as you get comfortable, we're going to throw you right back into the deep end of the pool. And we only got a couple more episodes before the season wraps up, and we hope to see you next week. So thank you guys so much, and good night.